Okay, we're back with the second video of the day. Added another coin just for fun. It's this one right here. It is just some 10 pence from Britain, from the United Kingdom. All right, so we got all kinds of fun money here. It's all, if I add it all together, it's less than $2. So that's why I have them. Okay. So we should have written down some, let's get rid of those and we'll draw some circles later. Probably leave that one out. Inscribed angles, intercepted arc, and subtend. There's a couple words we needed to do here. That should already be in your book. We also did inscribed polygon and circumference of a circle. Or no, I'm sorry, circumscribed circle. All right, so we're going to go over the theorems kind of and how this is going to work for us. And so we'll go ahead and get started here. All right, so an inscribed angle. Inscribed is an angle whose vertex is on the center, I'm sorry, not on the center of the circle. It's on the circle. Okay, and so this is something, if we were in person, I would push every single day. Inscribed circle is going to be here. So this is inscribed. Okay. There's a different word for if it starts in the center of the circle. And if only math weren't so creative with their names, we would know what that is. Does anybody know what that is? I believe that is called the, what is it? Is it the central angle? So if it's in the center, this is a central angle. I won't put the symbol, I'll just write the word. And this is the inscribed angle. So that's the difference. And it basically comes with a theorem or a formula. So the measure of an inscribed angle theorem, I'm going to write it not like in the book, I'm going to write it algebraically. So here's the middle here. And so basically what this would be is, I'm going to put some variables here. I'm going to call this x. Okay, that's the angle. And I'm going to call the arc right here, I'm going to call that y. Okay, so x equals 1/2 of y. Okay, so basically the angle is going to equal 1/2 the arc. I like to look at like a movie theater. Let's make sure we have that all shown. Let me get rid of that title. Race. Let me get rid of that title. So the angle is going to be 1/2 the arc. Is basically what this means. Let's look at the central angle here. The central angle, and I'm not going to use x, y. I'm going to use a and b. It is a equals b. The angle equals the arc. Okay? So that's what's going on with the inscribed angle. So that's basically what we need to do. And like I said, I like to look at this like a movie theater. You know, you got your camera. There we go, my beautiful camera. And it projects on a screen. Okay? In this case, our screen is not flat. Our screen would be curved. And so the angle here, so we call that x, this arc is going to be twice as big. Okay? Okay, and let's put some numbers to it here. Let's put some numbers to it here. And see if we can do a problem like this. Let's get it real quick. All right, and so I'm going to just go ahead and draw something. Okay, and I'm going to draw some numbers here. I'm going to call this, let's call this 75. That's probably close to 75. I want to know what x is. Well, the angle is 75. So what's the arc going to be? Another way to say 1/2 x, I could rewrite it as 275. 2 times 75 equals x. So the camera's a smaller angle and the screen would be a total of 150. So x would be 150. So that's how that works. Okay. I'm just wasting paper here. That's just ridiculous. So let's move on. Let us move on to the next one. Inscribed angle of a circle theorem. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. Okay, that makes sense. If they share the same arc, then they're congruent. So I'm going to kind of show you a problem that you might be facing in your work here. And so we might have something like this. Okay, and we might have A, B, C, D. Yeah, that's ugly. Okay, I want to look at I want two congruent angles out of this deal. Okay, and so let me just focus on this. There might be multiple ways to do this, but let's focus on this. I see this angle right here, angle A. Okay, angle A is going to project on to this arc right here. I also see angle B, and I wish I had another highlighter. I don't. So I'm going to color purple. All right. See how both of these angles project on the same arc? I wish I had another highlighter really badly. Just don't do it. I'll go find one for tomorrow. All right. So they both project to the same arc. So I would say that angle B is congruent to angle A. That's as simple as that, and that's one of your problems. So that should help you out a little bit. All right, so that's basically how these work. I'll let you play with some of these. Don't make them too hard. That's why I'm tagging these together. So then we got into the inscribed right angle theorem and the inscribed quadrilateral theorem. And so I probably need to break those down just a little bit here. There's a lot of words for the inscribed right angle. So an inscribed polygon is when all of the vertices lie in the circle. Okay, so basically what that means is we got our circle. Okay, and it is inscribed. And I'll do just like a little inscribed triangle here. And there we go. So it's inscribed. All of the vertices, that means nothing sticks out of the circle. So I have a nice little inscribed, beautiful little triangle there. Okay, if this was a right triangle, let's call it a right triangle. Sure, might as well. If it is a right triangle, then it is inscribed, and it is inscribed in a circle, then the hypotenuse is the diameter. Okay, so if this really were a right triangle, then that would mean that this would be a diameter, which means the center of the circle would be there. I don't think that this would be a right triangle because that can't be the center of the circle. But if it was a right triangle, that would have to be the center of the circle. This would be a diameter. Conversely, it works both ways. If one side of the inscribed triangle is a diameter of the circle, then the triangle is a right triangle. Okay? So in this case, probably the center is really about here. So this would not be a right triangle. But if it were, diameter, there we go. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Okay, that seems very similar to what we've had before. So let's go ahead and look at, let's go ahead and look at a couple of these problems and see if we can figure them out. Okay, you may or may not have these problems, but they're going to be similar problems to what you do have, because my goal is to have similar problems so you can understand the problems that you do have. Sometimes I do the exact problems. So let's go ahead and do this here. I might need more room. And we'll put one down here for later. Okay. So we might have a problem like this. Let's see if we can make this work. All right, that would be an inscribed quadrilateral. It's not the best drawing in the world, but it does work for our purposes. I'm going to label it. We're going to call that X. We're going to call this Y. By that I mean 2I. We're going to call this over here 60. And we're going to call this over here 60. Okay. Well, the theorem says that opposite angles are supplementary. So that means that X and 60, let me do this. These are opposite angles, right? That means X and 60 are going to equal, X and 60, not 16, are going to equal 180. So X is going to equal 120. All right. So again, opposite angles. So these angles are opposite. So they're going to equal 180. So that's 2y equals plus 60 equals 180. 2y equals, I'm popular right now. I'm going to finish my video before I answer the phone. 2y equals 120, so y is going to equal 60. All right, so we got it going on that. So we need to look at that right triangle kind of problem. We're definitely going to have one on our thing, so let's make sure we can understand those right triangles. Okay, this picture isn't perfect, but it's close, so we're going to call this 34 degrees. We're going to call this 3x, and we're going to call this 2y. And we're going to put the center of the circle here, which means, if this is the center of the circle, this is diameter, which means that this is going to be a 90-degree angle, right? Because if the hypotenuse is a diameter, that means that this is going to be a 90-degree angle here. So that means 3x equals 90. X equals, divide by 3, 30. And then 2y will be easy, because 2y plus 34 plus 90 equals 180. I think that's going to do it for us. Again, if you have questions, I don't want to overdo this. I want to make these videos shorter. So again, if you have questions, ask them, and then I'll answer them in the following day's video. And there should be one more video today, and it will cover any questions that you do ask today.